This, plus a Raspberry Pi, is probably the cheapest Amiga Accelerator out there. They say you get what you pay for, but this might be an exception.
Hello and welcome back to Noel's Retro Lab. Today we're going to have a good look at the PiStorm accelerator for the Commodore Amiga. This is not going to be an installation guide, I'm warning you. There are plenty of those already out there and they can do a much better job than I can. Instead, this is going to focus more on how the accelerator works, what we can do with it, and why you'd want to do it. You have probably already heard of Amiga accelerators before, things like the Vampire, which promise to completely transform your Amiga into a beast of a system. I had looked into those at some point in the past and I was really excited about them until I saw the price tag. I have a hard time justifying accessories that cost close to as much as the system itself, but when they're many times higher, that might be okay for an Amiga power user that wants to squeeze all the power out of an Amiga, but I'm just a casual Amiga user and I quickly decided that I had no need for those accelerators. So enter the PiStorm. When I first heard of it, I didn't give it a second glance. Another expensive accelerator, not for me, I thought. But then I saw it wasn't just as expensive as other accelerators. As a matter of fact, it was listed as costing only 15 euros. What? I thought, that is worth looking into, even for a casual user like me. At this point, I was really excited about getting into Amiga accelerators at a price point that made sense to me. So I did some reading, watched some excellent videos on the topic, and I walked away with some doubts. It looked like the project was in its infancy. It worked, but it was hardly a fire and forget solution. Instead, it looked to be more of a device to tinker with, but not a permanent add-on that you could leave on your Amiga. So let's say I wasn't ready at all for what I found. So what exactly is an accelerator anyway? It's a device that usually replaces the CPU and behaves like the CPU itself, but faster. And sometimes a lot faster. If the system supports it, it can also behave as a different, more powerful CPU. Up until now, this has been done with FPGA boards, which was necessary to be able to run things quickly enough. But technology keeps advancing, and tiny microcomputers like the Raspberry Pi are getting faster and faster. So the PiStorm is implemented with a Raspberry Pi running Raspberry OS, which is a kind of Linux, plus some logic to interface with the rest of the system. Specifically, it uses the Raspberry Pi 3 Model A+, which is a pretty potent and compact one. So yes, we're using a computer to replace the CPU, which if you think about it, it gets really bizarre, but we'll come back to that later. But of course, once you've gone to the trouble of emulating a piece of hardware, either in software or with an FPGA, we don't really have to stop there, because once you're hooked to the CPU spot, it means we have pretty much access to all the important signals on the computer: data bus, address buses, and most control signals. And the PiStorm does exactly that. What else would it be handy in addition to the CPU? Well, more RAM, of course. Okay, we got that. How about a hard drive? That's always one of those useful upgrades on the Amiga. Sure, let's throw one of those in too. Oh, wouldn't it be handy if we could emulate the ROM from there too? Sure, why not? The PiStorm doesn't even stop there. It also adds a real-time clock, network card emulation, and even advanced graphic modes like the RTG. All of that with a Raspberry Pi. I don't know about you, but I'm kind of blown away with the idea of it all. Before we get into the details, let's actually give it a try. I said this wasn't going to be an installation guide, but I kind of lied a little bit, and we're going to cover how to install it. However, we're going to do it in the really easy way. If you choose to install things manually, it can be a long process. Install Raspberry OS, download the PiStorm project, get dependencies, configure everything, transfer software over. You can easily spend hours doing that, and for that, go ahead and watch other videos. Or you can do what I did and just download a disk image ready to burn into an SD card already fully configured. I used one created and maintained by one of my favorite retro forums, RetroWiki. I put a link to it below in the description. Just keep in mind that it's mostly a Spanish forum. I'm sure you can find similar images in other communities and maybe even in the PiStorm Discord server, which seems to be pretty active. Once you have one of those images, you need to burn it into an SD card. I used the official Raspberry Pi Imager app, and in a few minutes, it's ready to go. I want to be able to configure everything through Wi-Fi, so for this time only, we need to connect the keyboard and the HDMI out to the Raspberry Pi. As you can see, this looks like a regular Linux distribution pretty much. So now we can run our setup program, enter the Wi-Fi settings, and we're ready to work with it remotely. This will be the last time we ever need to use the keyboard and monitor directly plugged in into the Pi. Since this comes already configured to load a ROM from the SD card, the last thing you need to do is copy your Kickstarter ROM in place. And once you've done that, it's time to assemble the PiStorm hat. Really, all we have to do is connect the Raspberry Pi to that separate board. Make sure you get the orientation right though, because there's no keying or any other indication in the connector. And now we can finally replace the CPU with it. So we carefully remove the 68,000 CPU. Wow, so many pins. I'm not used to that after working with Z80s and 6510s. And now we put the PiStorm in place of the CPU. One last push, and yeah, that's all we have to do. Could it really be that easy? Let's find out. I'm going to turn it on now. I see the lights blinking, so there's definitely some activity going on in there. And oh wow, it worked first try. That was amazing. And you know what was awesome too? How quickly it booted up. One of my fears going into this was that there would be a significant delay between turning on the computer and the Amiga starting up. After all, the PiStorm is not a bare metal application like the RGB to HDMI one. In this case, the Raspberry Pi is running Raspberry OS, and in the past, when I've timed it, it takes a good 20 seconds or so before it's ready. But in this particular image, it's set up to specifically boot up as quickly as possible. It's using Diet Pi, which is a particularly light distribution of the operating system, and it loads as few services as possible at startup. That means it can boot up in just 4 or 5 seconds before the CPU emulator is active and the Amiga is ready to start up. So waiting a few more seconds isn't too bad, but notice that it actually booted from the Workbench disk image on the SD card, which is way faster than booting from the Gotek. So let's compare the before and after. I started them both at the same time. With the PiStorm, it took 15 seconds to load Workbench 3.1. Before I was booting Workbench 1.3 from the Gotek, which is the same speed as a floppy disk drive, and that just takes forever in comparison. As a matter of fact, it took 54 seconds, and I'm sure Workbench 1.3 is a lot smaller than the version we used with the PiStorm. So that right there turned from one of my biggest fears into a huge win. The CPU in an Amiga 500 is a 68,000 running at 7 MHz, but by default, this image came configured with a 68040 CPU, and that's not just a minor upgrade. The 68,000 is a 16-bit CPU, but the 68040, apart from being much faster, is a full 32-bit CPU, and it has a built-in floating point unit. So yeah, a program that takes advantage of those features should be much faster. The exact PiStorm configuration is controlled through a simple text file, which we can access by simply using SSH into the Raspberry Pi running Linux. There you can see that the CPU in this case was set to a 68040, and let's see what sysinfo reports with the setting on. Yep, you can see that it detects that it's 68040, and it has a floating point unit and everything. So let's run the benchmark to see what it reports. And it claims to be 44 times faster than a stock Amiga and about 25% faster than an Amiga 4000. Of course, take all of that with a grain of salt, since this is an artificial benchmark, but it's an interesting point anyway. Just to see how easy this is, let's go back to the configuration file and replace the CPU with a 68020. That's usually plenty, since I believe most Amiga programs are compiled at most to take advantage of the CPU and nothing higher. And that way we minimize any potential incompatibilities too. Let's restart the Amiga, run sysinfo again. And there you go, it shows that it says 68020. Interestingly, the performance is listed as almost the same as when we had the 68040, so I don't know if that's a glitch with sysinfo or the emulator just keeps going as fast as possible, and so both CPUs end up with similar speeds. I actually tried changing the configuration file back to a 68000 CPU, which is the stock Amiga one, to get some benchmark comparisons, but all I managed to do was either get a blank screen or a flashing yellow one, which indicates a bad CPU. After some digging, it turns out that the PiStorm doesn't support the plain 68000 configuration, and the lowest it can go is a 68020. That seems a bit odd, since maybe you'll want a 68000 for some weird compatibility problems, but maybe there will be something that we'll get at it later. On that same config file, we can swap out the ROM file that we want to load, or if we comment it out, the Amiga will use the built-in ROM as usual, and there you go, it's booting from Workbench 1.3 from the Gotek with the system ROM, but it still has all the extra RAM and the 68040 CPU. Speaking of RAM, let's have a look at it. it shows that we have about 128 megabytes of free RAM, and that's pretty mind-blowing for someone like me who's used to having an Amiga 500 with 512 kilobytes of RAM and a trapdoor expansion that brings the whole to a whole whopping 1 megabyte of RAM. This to me feels more RAM than you would ever want, which is great, except that there's a slight catch in there that we'll see in a moment. As you can imagine, the RAM is also configurable through the same text configuration file, and there you can control the amount of RAM and the exact type of RAM you want. Normally, hey, the bigger the better, but you may want to specify smaller amounts for compatibility reasons. Up until now, we've been using some other computer, accessing the Raspberry Pi through SSH and editing the configuration file there. It's nice and convenient, but it requires using a different computer, which is not always ideal. Sometimes it can be nice to be able to use the Amiga as a fully standalone computer, and we can do that with some special PiStorm software. First of all, we can run the pi command from the Amiga shell, and that drops you straight into the Linux shell itself. It starts getting a bit weird, realizing you're accessing the Raspberry Pi, emulating the CPU of your Amiga through the Amiga itself, but it's pretty great. The only problem is that some of the terminal layout doesn't seem to work well, at least the way I have things configured. So for example, here the Pico editor gets chopped off and hard to work with. Also, instead of making these configuration changes one at a time on the config file, you can have multiple files ready with different configurations, so you can just swap out the file you want much more easily. That's particularly handy if you have configurations set for specific loadouts, kind of like a 68020 Amiga with 2 megabytes of RAM, a fully upgraded 68030, etc. The PiStorm also comes with a PiStorm control program that lets you load those configuration files from within the Amiga UI itself. So here I'm running the 68040 emulation and I'm going to load the 68020 configuration. So I have to type the full path to the configuration file that I want to load, and then it restarts the emulator with the new configuration. And yeah, that looks different already. Let me check with the sysinfo. Yep, there it is, running the 68020. Neat. So what do we want all that RAM for? Some of the later games in the lifecycle of the Amiga required more RAM, but one of the main reasons for needing more RAM is WHDLoad. The PiStorm will emulate a hard drive interface, but a lot of Amiga software wasn't intended to be loaded from a hard drive. WHDLoad is a layer in the middle that lets you install and run software from a hard drive in a pretty seamless way, but it does use some extra RAM, so having lots of it will let games run without a problem. And even for die-hard fans of loading games from disk or GoTech like me, I have to admit that WHDLoad is a game changer, especially for games that require more than one disk. You can browse all the games loaded in one of your hard drive images, launch them, and have them executed in a fraction of the time that it would have taken from disk, not to mention you don't have to change disks. And best of all, this works side by side with loading from floppy. It's not one or the other. Unfortunately, not all games will load and run correctly. In this case, Lemmings won't run because I don't have enough chip memory. And that's because the RAM emulated with the PiStorm is just fast RAM or CPU RAM, and Lemmings needs more chip RAM, which is the memory dedicated for video and audio chips. Could the PiStorm emulate that in a later update? I'm not sure. It would be great, but being RAM intended for those chips, it's possible that some of the control signals aren't accessible from the CPU socket, and if that's the case, it may need some extra wires to do that. Here's hoping to do that in the future, and in the meanwhile, I should just get myself a chip RAM expansion in the trapdoor, since the one there now is just for fast RAM, and we have plenty of that with the PiStorm. So let's talk for a second about running games and acceleration. Normally, we think about having a computer that is as fast as possible as a good thing. Opening a window will be faster, files will load faster, and everything will be more responsive. Great! So how come that when we played Turrican, the music was playing correctly and the character moved at the right speed instead of 40 times faster? It turns out most 2D games like that one will not be affected by the acceleration. There's no way they'll have more frames of animation because that animation is individual sprite frames that were authored that way, and that's it. You can't get any smoother animation with what you got already. Usually the bottleneck in those games is also the blitter copying images into the screen, and acceleration isn't going to make that faster either, which is actually a good thing, because if any kind of arcade game started running faster than usual, it would become way too difficult and unplayable. So fortunately, things work the way we want with those games. There are other games that do benefit from an accelerator though. The first category of games are those that are bottlenecked in the CPU. Games in which the CPU spends a while analyzing what it's going to do and then performs that action. You can see this in games like chess, or even turn-based games like Civilization, which incidentally is one of my all-time favorite games. The computer before would spend maybe 20 or 30 seconds waiting to make its move. Now it just churns through all those possibilities in a fraction of the time and makes its move much more quickly. So that's a big win for the accelerator. In the 90s also, Amigas were a great choice for graphics work. There were many applications that would do graphics rendering, and that would be completely CPU bound. These days, with PCs that are thousands of times more powerful, there isn't really a strong reason to use those programs, but if you choose to do that, this kind of CPU accelerator will make them much, much faster. The category of games that will probably most benefit from an acceleration are 3D games. Unlike 2D games, 3D games are typically CPU bound and they don't have any set of pre-authored animation frames. So speeding them up on the CPU allows the game to run at a higher frame rate and have smooth movements and animations. You can see that very clearly in examples like Wing Commander. Without the acceleration, it's running at what is that, 5 or 8 frames per second? But then we change that and put the PiStorm, and suddenly it becomes much smoother. Honestly, this is how the game should have been from the start. This is probably how it played on a high-end PC at the time, and what the developers were probably trying to achieve when they ported it to the Amiga. So by using the accelerator, you're getting the ideal gameplay experience. Here's another great example, Formula 1 Grand Prix. The default Amiga 500 experience is very underwhelming. The frame rate is really choppy and it's even hard to see what's going on and at that low frame rate. Now turn on the accelerator and yeah, that's what I'm talking about. Now it's definitely playable. I would go as far as to say that some kind of CPU accelerator is definitely required to enjoy most 3D games on an Amiga 500. So maybe we should ask the opposite question. Is there anything that will not work with accelerators like the PiStorm? And yes, there are a few things, and that's why you want to have different configuration files so you can swap them easily. So apart from incompatibilities with higher CPUs, there may be some 2D games that are not properly frame locked, and playing them on a faster CPU makes them just go faster and become unplayable. I actually wasn't able to come up with an example on an Amiga, but that happened a lot on early MS-DOS games, which just assumed that they would always run at the same speed CPU, probably like a 5 megahertz or something. Little did they know things would change. A related case on the Amiga are games that are trying to do really fancy hardware tricks, and those might fail under acceleration. This is something you may see happen on demos, which try to push the limits of what the hardware can do, so they may run into all sorts of weird cases. For example, it was a pretty common practice to set a timer to go off at some time in the future, then have the CPU execute some code and assume that when the timer interrupt went off, the CPU would be at a particular point in the execution. That could be used to do fancy graphic effects by changing palettes or other settings mid-frame, for example. But now that the CPU is running 40 times faster, clearly the CPU and the timer will get out of sync. Fortunately, as people report those cases, the PiStorm project might be able to fix some things and adapt to those, so they fix them. So I can only imagine that compatibility with weird demo effects is going to continue getting better over time. The one missing piece to make the PiStorm into the perfect accelerator is a simple way to be able to transfer files to it. We could create a hard drive image, put that in the Raspberry Pi, and let the Amiga access them. But that would be a lot of work and it would be pretty cumbersome. It turns out there's a much better way. The PiStorm went beyond just accelerating the hardware and it started taking advantage of the Raspberry Pi hardware itself. So it's possible to configure a shared directory on the Raspberry Pi over Wi-Fi using the Samba protocol, but also map that same directory on the Amiga OS as a disk drive. The result? We can see that share from any PC and copy to it whatever we want and it will appear on the Amiga. To test it, I'm copying Monkey Island to it right now. And then on the Amiga, we open up the disk drive and we see that the contents are there. Now, we don't want to execute them from there directly because that drive is pretty slow. but we can just copy the contents over to another one of the hard drive images. And now that it's there, we're ready to launch it. There you go, Monkey Island. And that also works the other way around too, so it may be a nice way to share files from an Amiga to other Amigas, or even as a way to download them onto the PC for a backup. So how far can we keep taking the PiStorm? Is there something else it can do? It can already do a bunch more things than I talked about, and it can probably do a bunch more down the line. So the sky is the limit for this project. For example, the PiStorm supports RTG through its HDMI port. RTG is retargetable graphics, which is a way the Amiga has to support graphics at higher resolutions than the default. So with just a little bit of tweaking, you can get the Amiga to output higher resolutions through the HDMI port of the Raspberry Pi, which is perfect for like a modern LCD screen. I didn't explore that because I don't really have a need for that at the moment, and I prefer to use my CRT monitor over an LCD one at the moment. Besides, the HDMI port on the Raspberry Pi is stuck inside the case, so you'd have to get a cable in there somehow. So what else is there? We already made use of the Wi-Fi on the Raspberry Pi for accessing it through SSH and having the shared folders, but the PiStorm can go beyond that. It actually emulates the A314 network expansion board, so if you install the TCP/IP stack, you could pretty easily access the intranet from your Amiga. Okay, so that actually doesn't sound that interesting if you're just thinking of browsing a website, but it could open the door to things like app updates, global high score for games, and even multiplayer networked games, so that's pretty cool. One more thing that I don't think is supported at the moment, but which could be very interesting, is the use of the USB port on the Raspberry Pi. So just like the HDMI port, it would be great if it could be exposed externally, and then it could be used to access USB drives, but maybe also USB accessories like mice or gamepads, so hopefully that's something else that is coming down the line. There's an almost philosophical issue I wanted to bring up, and that's the role of the Raspberry Pi in this simulation. I've used Pis before in things like RGB to HDMI project, and I had no problem with it, but that was very different. There, the Pi was taking an output generated by the computer, a video signal in that case, and processing it into something else. Conceptually, it wasn't that different from a video scaler connected to a computer or even the processing happening inside a modern TV. Here, however, the Pi is at the heart of the computer. Remove the Pi and nothing else works. It becomes a fundamental part of the Amiga itself. And the Pi also doesn't just emulate the CPU, it emulates memory and ROM and disk drives, network adapters, and more. So why stop there? Should the Raspberry Pi just emulate everything and we just use the Amiga keyboard as an input device? We could, or maybe right now the Raspberry Pi can't do everything, but probably in another generation or two, it could emulate everything, every single chip in the Amiga. Is that what I want? I don't know, maybe, I don't think so, but then it's probably okay as long as I can use the keyboard and all the ports, but there's a line in there, it's definitely something fuzzy. It's like, it's okay to have the CPU replacement, but when does it become too much? It's kind of like FPGAs. I love the idea of small FPGAs replacing individual chips, but I'm just not crazy about FPGAs that emulate a whole system. So philosophical issues aside, I absolutely love the PiStorm. But there's one thing that is nagging me a little bit, which is the PiStorm is using a Raspberry Pi with some version of Raspberry OS in it, which is a variation of Linux. And as far as I know, if you just turn Linux off without going through its shutdown procedure, you could run into some problems like corruptions of tables or settings or something like that. And the Amiga doesn't really have a command that can be tapped into the PiStorm to initiate the Linux shutdown. So you're forced to just turn the power off when you're done. So far, I haven't had any issues, but I'd hate to turn it on one day and find that the configuration was corrupted because of that. The ideal solution would be to turn the PiStorm into a bare metal application, but that would probably require re-implementing a lot of things to keep similar functionality to what we have right now, like share folders over a network or allowing SSH to change configurations. A bare metal implementation would also speed up the startup time though, so that would make the PiStorm even better than it is right now. I mentioned before that the PiStorm was a cheap accelerator. So how cheap exactly, and compared to what? Remember that the PiStorm is an open source project, so the cheapest option would be for you to download the Gerbers, print your own PCBs, and solder the chip, the CPLD, and the other couple of chips yourself. Unfortunately, right now we're in the middle of a chip shortage, so prices have increased quite a bit. But just a few months ago, you could have gotten all of that for about 15 euros. Now the CPLD is somewhat more expensive than that, but still maybe within reason. Then on top of that, you still need the Raspberry Pi 3, which if you don't have one already is about 25 euros. So at a bare minimum, you're looking at 40 euros for the full PiStorm acceleration package. If you want to buy the PiStorm hat already assembled, which is not a bad idea because there's some tricky soldering going in there, you may need to spend around 40 euros for that, so that's a total of 80 euros. Suddenly, that doesn't sound like an accelerator on the cheap like I promised at first, but keep in mind that an FPGA accelerator like the Vampire 500 V2 Plus costs 400 euros and it looks to be out of stock everywhere at the moment. I haven't tried the Vampire myself, and I hear it's faster and more mature, and I don't doubt it for a second. But the PiStorm is between 5 and 10 times cheaper, so that certainly makes it a standout, and you know the PiStorm is only going to keep getting better and better over time. So final thoughts? Really, there's nothing I haven't said before. I am absolutely blown away with the PiStorm. I expected to find a clunky, difficult to install tech demo, and I found a fully functional accelerator that completely transformed the Amiga 500. I also expected to put it in, give it a try, and then just pull it out of the Amiga until next time I played with it. But I'm actually living it inside the Amiga. This is how I want to use my Amiga going forward. So that says it all. Anyway, that's all for today. There's actually a lot that I didn't cover, like using a different emulator for the CPU, which there's a faster option than the one that is there right now. So I'm sure I'll revisit all of this in a year or so and cover some of the new advances and some more details. So I hope you enjoyed this episode. If you have any comments, let me know below as usual, and I'll see you next time.
If you enjoyed this video, please consider supporting Noel's RetroLab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.